Hello students and welcome to Smart Kids Tutorials. In this video, we will be solving Goa Board's model paper for class 9 mathematics paper for the first semester 2025-26. Okay, let's go through the instructions really quickly. Okay, the question paper will consist of 43 questions and all questions have to be answered. The question paper will be divided into 4 sections A, B, C, and D. In section A, the question numbers 1 to 20 will be multiple choice questions. And question numbers 19 and 20 are assertion reason based questions of 1 mark each. In section B, question numbers 21 to 31 are short answer type questions carrying 2 marks each. Section C will be question numbers 32 to 41, again short answer type, but they will be questions that will be carrying 3 marks each. In section D, question numbers 42 and 43 are long answer type questions carrying 4 marks each. So there will be no overall choice. However, an internal choice will be provided in 2 questions of 2 marks each in section B and 2 questions of 3 marks each in section C. In the question on construction, the drawing should be clear and exactly as per the given measurement. The construction lines and arcs should also be maintained. Use of calculator is not permitted. You are requested to read these instructions carefully at the beginning of the paper to avoid any confusion and problems later on, because there are sometimes problems wherein one sheet of the paper is not printed, and so you those who do not check their papers end up losing marks later on. Okay, so no need of crying later on. You first have a look at your question instructions which are written. Check if you have section A, section B, section C, and section D clearly printed on your question paper. Once you're satisfied that question numbers 1 to question number 43 is present on your question paper, you can then proceed to answer your paper. But just have a glance, just have one glance, no need to think deeply through the paper. Just glance through the paper to see all questions are there or not there, and if things are given properly. Okay, and then you can start answering the paper. So in this uh, uh, so here we will be answering section A, which will be for 1 mark each. So let us begin first. So these are MCQ type questions, and where you will be given 4 choices and you will have to choose one among them, so whichever is the right one. So even if you do not know the answer, I suggest you choose at least one from there, because in case if it happens to be correct, you will get 1 mark. So there are no negative marks for choosing the wrong answer. So rather than just leaving it blank and not answering it, why not just answer one? And who knows, if it is in your luck, you may get that 1 full mark. So there are no half marks. Either you will get a 0 for answering the wrong question, or you will get 1 full mark. So please do answer each and every question. Okay, so let us begin now answering the section A over here. So select and write the correct alternative from those given below each statement for questions 1 to 20 itself. The first question is the decimal representation of a rational number is, the choices are always terminating, either terminating or repeating, either terminating or non-repeating, neither terminating nor repeating. So we can rule out this last one, because then it will not be a rational number, it will be irrational if it is neither terminating nor repeating. Now we should know from our theory on rational numbers that a rational number is something, okay, which on division, okay, of the fraction, it should give us either a terminating, uh, it should either be terminating or it should be repeating. Okay, it can't be just it's not always terminating, and it can't be either terminating or non-repeating. No, it should be terminating or repeating, not terminating as well as repeating, but terminating or repeating. So either you will get 0 as the remainder, or if you don't get 0 as the remainder, the number in the quotient will keep repeating, either 1 number, 2 number, 3 number, whatever it is, but it should show a repetition. Okay, so our correct answer is B, either terminating or repeating. So I'm going to write it up over here. So first answer is either terminating or it should be repeating. Okay, so that is the quotient we are talking about. This is the um, uh, remainder we are talking. The remainder should come 0. Okay, so here you go. So one example would be for you if we divide 20 by 4. Now this will be give you 5 as the quotient, but the remainder will be 0. And the other one you can try, you must have solved in the class also, wherein you have 22 upon 7. So this will give you a recurring number, okay, wherein the quotient will keep on repeating after few digits. So these two are rational numbers. Okay, let's proceed further, and we'll go to question number 2. Okay, question number 2 asks us which of the following is an irrational number. We are giving you 4 choices, and let us solve each and every choice to rule out the ones which are rational numbers. Okay, read carefully. It says we have to find out which one is an irrational number. So we'll start with the first one, which says root 24 upon root 6. Okay, so we'll see root 24 upon root 6. Now, is this a rational number? Let's see, or any rational number. Root 24 can be written as root of 4 into root of 6 upon root of 6. Root of 6 and root of 6 will cancel, and root of 4, square root of 4 is 2. So, which means A is a rational number. So, this is not our correct choice. Let's look to B. B is root 5 into root 5. Let us see. Root 5 into root 5 will give us 5. Again, it's a rational number. So, B is not our correct choice. Let's go to C. Okay. C says square root of 4 upon 9. Okay. So, we'll say square root of 4 upon 9. So, is as good as saying square root of 4 upon square root of upon square root of 9. Square root of 4 is 2. Square root of 9 is 3. So, which means this is a rational number. That leaves us with the final choice. So, that has to be irrational. Let's look at it. Root 5 into root 3. So, root 5 into root 3 can be written as root of square root of 15. This is a irrational number. Okay. So, our correct choice is D. B is the correct choice. And sorry, I did write the correct choice over here in the case of first one. So, we'll take it as either terminating or repeating. B would be the correct choice. Here it will be D. Let's move to question number 3 and see what are we getting. Degree of the polynomial 5x cube minus 7x square plus 9 is what? Okay. When we speak about the degree of the polynomial, we look at the highest degree in that polynomial. Okay, this full thing is a polynomial, but what we look at is the highest degree. So when it refers to degree of the polynomial, it refers to the highest power of in that particular polynomial of that variable. So now the power of x here is 3, power of x here is 2. Here you can here the power of x will be 0, which means the degree of the polynomial is got to be 3. So D will be our correct choice, which is 3. So we'll say 3 is the correct choice, and the correct choice is D. Okay. Moving to question number 4, it says when x cube minus 5x plus 4 is divided by x plus 1, the remainder is one of these. So how should we solve this thing? Okay, we'll take we have been given here as we'll take p of x equal to x cube minus 5x plus 4. Okay, and we'll take g of x as x plus 1. Okay, so if we take g of x equal to 0, we'll get x plus 1 equal to 0, which means this will imply that x will be equal to minus 1. This minus 1 we can substitute in this polynomial. So p of minus 1 will give us minus 1 whole cube minus of 5 into x will be minus 1 plus 4. This will give us minus 1. The minus 1 whole cube means minus 1 into minus 1 into minus 1. So minus 1 into minus 1 gives us plus 1. But plus 1 into minus 1 gives us negative 1. That's why negative 1 here. Minus 5 into minus 1 gives us positive 5. And we have positive 4. So minus 1 plus 5 gives us positive 4. Positive 4 plus positive 4 will give us 8. Okay, so 8 is our answer. Well, let's look if we have this number in our choice. So here we go. So it is the second choice, B. We will see. So B is the correct answer. Let's move to the fifth question and see what it is. Now the fifth question says, how many dimensions does a plane surface have? Okay, so a plane surface will have only 2 dimensions. Okay, it will have a length of the breadth. So the plane dimension will be like this. Okay, this is a plane dimension. For example, it will have length and it will have breadth. So there are only 2 dimensions. If you have 3 dimensions, it will have length, breadth and height. So this has only 2. So plane dimension has got only 2. So that means the correct answer would be C. Okay, that is 2. Question number 6 says the sum of the angles formed on the same side of a straight line at a point is one of these. Okay, so it says sum of the angles formed on the same side of a straight line at a point. So what does this mean? So see, question number 6, you have a straight line here. Okay, now when you have a straight line, what is this angle? Full angle. This full angle is 180 degree. So no matter how many angles come from here, if we take this as a center and if we have one line here, this, all this will form angles. This one, this one, this one, this one here, this one here. But the sum of all of them will be 180 degrees because this angle of a straight line is 180 degrees. So correct answer would be B, 180 degrees. Here you go, B, 180 degrees. Let's go to question number 7 and see what is the question. Which of the following statements is true? Okay, it's first question, choice is all adjacent angles are supplementary. Okay, so second one is vertically opposite angles are always supplementary. If two lines intersect, the adjacent angles formed are always equal. And the last one is vertically opposite angles are always equal. Now we know from our lines and angles chapter that vertically opposite angles are always equal. So definitely this one is correct. So we are made to choose only one from here. So we need not look or see if there is any truth in the other 3. We know that this is correct. So vertically opposite angles are always equal. So D is our correct choice. So we'll put D over here and write vertically opposite angles are always equal. Okay, we use it a lot in lines and angles and even in triangles. Okay, we'll be using it later on. Question number 8, we to see here in triangle PQR, if QP is equal to QR, S is the midpoint of PR and angle PRQ equal to 35 degrees, then angle PQS is one of them. So before this you will have to draw a diagram. Okay, just a rough diagram will do. There are no marks for constructing that figure. You just draw. So it says you have triangle PQR, right? So we just make a rough figure, triangle PQR. So I'm going to mark this as triangle P, Q and R. So P I'll take here, Q I'll take here and this will be R. Then we are told that S is a midpoint of PR. So this is PR. I'll take S over here as a midpoint. Okay. And we are told to find out angle PQS. So P, Q and S is here, which means we'll have to join this QS. Okay. Now we are told QP is equal to QR. QP is equal to QR. So I'll mark this, QP is equal to QR. Okay. And we are told S is a midpoint. Fine. Okay. And we are told PRQ is 35 degrees. So where is PRQ? PRQ, this is 35 degrees. Fine. We are asked to find out PQS. So PQS is what we need to find out. Okay, so we'll first write down what we have been given. We are given QP equal to QR. This is given. QP equal to QR, and write it down as given. Remember, the working does not have marks. Straight away you can write the answer. But I'm showing you the working so that you understand how we get the answer. So QP equal to QR given. Then we are told S is the midpoint of PR, which means that RS is equal to PS. RS is equal to PS since S is midpoint. S is midpoint of PR. Okay, PR. Now, done. Now what we'll do is we'll look to prove these two triangles as congruent to each other. So we'll say in triangle QRS, QRS, and triangle will take QPS. Okay. Now we are given QR equal to QP. So QR equal to QP, that is given. Okay. Then QS is common to both this triangle. So we say QS equal to QS, common side. Okay. Done. Next, we say that RS is equal to PS. Okay. So RS equal to PS because S is midpoint of PR. Okay. So we can now we can say these two triangles are congruent by side. So triple S. The triangle QRS is congruent to triangle QPS. This would be by triple S congruence rule. Okay. Now that we have proven these two triangles congruent, we will take two angles as CPCT. So corresponding parts of congruent triangle, which we'll take it as we'll take PQS equal to RQS. Okay, so we'll take angle RQS equal to angle PQS as CPCT. Which one? RQS equal to PQS. So these two angles now we have shown as equal to each other. Okay. Now we can see angle QPR, okay, is equal to angle QRP. Which angle? This angle is equal to this angle, we can say. Why? Since we are given that QR is equal to QP. So if the opposite sides of a triangle are equal to each other, we can say that the angles or you can the adjacent sides of a triangle are equal to each other. We can say the angles opposite to those adjacent sides are also equal. So that makes this angle equal to this angle. So but we have been given that angle QRP is equal to 35 degrees. Therefore, that will make angle QPR equal to 35 degrees. Okay, so that means this is also 35 degrees. Okay, now we'll take in triangle PQR, we'll say angle QPR plus angle QRP plus angle PQR equal to 180 degrees as sum of all angles of triangle. Okay, QPR is 35 degrees. QRP is 35 degrees. PQR we need to find out. We don't know what it is. And all this is equal to 180 degrees. 35 plus 35 is 70 degrees. 70 degrees when it goes on the other side, it will become negative 70 degrees. So it will be PQR equal to 180 degrees minus 70 degrees. 180 degrees minus 70 degrees gives us 110 degrees. Okay, now we've got that, and you will say, now what has that got to do with what we want to do? Well, that has got everything that we want to do with this question. The thing is, PQR is this, right? Now PQR is what? PQR is nothing but, we can write it as angle PQS plus angle RQS. We can write PQR is equal to this angle plus this angle, equal to 110 degrees. But here what we have said in simplicity, we have said that PQS is equal to RQS. This is equal to this, you said. So we can write angle PQS plus angle PQS equal to 110 degrees. So RQS have replaced by PQS because RQS is equal to PQS. PQS plus PQS will give us what? 2 times angle PQS equal to 110 degrees. This 2 means 2 into PQS. If you take 2 on the other side, it will become division like this. 110 upon 2. That will give us 55 degree. Now let us see if 55 degrees is there in our choice. There you go. Fine. PQS, yeah, B. So B is our correct choice. Right over here as B. Question number 9. If the diagonals of a quadrilateral bisect at right angles, the figure formed is. So if you have a quadrilateral, okay, which bisect at right angles like this, okay, like this, that means it is a rhombus. Okay, so it is a rhombus. So if you have a quadrilateral which bisect at right angles, so then it will become a rhombus. So correct answer is rhombus, and we'll see which is the choice in this case. So D is our correct choice. Right over here is D. Go to question number 10. It says the value of tan 30 is what? Now the value of tan 30, you should know that it is 1 upon root 3. So B is our correct choice. So tan 30 degrees is equal to 1 upon root 3. So B is our correct choice. Question number 11. In the figure, the value of cos theta is what? Okay, I'll draw this figure here. So it will be easier to explain. Here the figure is given, and here you go. And we are given theta here. Okay, there is root 5 over here, there is 2 over here, and there is 3 over here. Okay, so I will just replicate the same figure. Root 5 here, 3 here, 2 over here, and this is a right angle over here. There you go. Okay, and we are asked to find cos theta. Okay, now cos theta is what? Cos theta is the base upon hypotenuse, or you can call it as the adjacent side upon the hypotenuse. Okay, theta is here, so its base is where, or its adjacent side is this one. Okay, and hypotenuse is where, this one. Remember, the hypotenuse is always the longer side, and it is always the side which is opposite to the right angle. So that makes this as a hypotenuse. So we will get the answer as root 5 upon 3. Let's look at our choice. So that means D is the correct choice. I put D over here, and we'll go to question number 12. Now question number 12 says the real number that lies between 2 and 3 on the number line is this. Okay, real number that lies between 2 and 3 is this. Now how do we, it looks confusing, but it is actually not. Now 2, okay, square root of 4 is what? Is 2, correct? And square root of 9 is what? 3. So we are given these numbers, and these are lying on the number line. So if we have a number line over here, okay, so instead of 1, we can write it as square root of 1. Instead of 2, we can write as square root of 4. Instead of 3, we can write square root of 9. Instead of 4, we can write square root of 16. Okay, these are all numbers. So we don't read it as square roots, but we know square root of 1 is 1, we know square root of 4 is 2, we know square root of 9 is 3, we know square root of 16 is 4. What they are asking us is which are the numbers which is a real number lying between these two. Okay, so now we can rule these two out from here. Okay, and we'll see. So we have got root 3, right? So root 3 comes before root 4, right? So we rule root 3 out because we said root 4 to root 9. So root 3 will come somewhere here, right? So we don't need root 2, we don't need root 3 because we are asked for a number between root 4 and root 9. That means we don't want root 4 also, we don't want root 9 also. Something in between this. So we rule the second one out also because we are asked for a number that lies between 2 and 3, not including 2, not including 3. So root 3 excluded, root 4 excluded. Root 7, yes, because root 7 will come between root 4 and root 9. Okay. What about root 10? No, because root 10 will come after root 9 and we are asked for a number between 2 and 3. So that means root 7 is our correct choice and that would be C in this case. Okay. Question number 13. It says if x plus y equal to 5 and x square plus y square equal to 111, then the value of x cube plus y cube is what? Okay. Now, looks quite confusing here because it just gives you x plus y equal to 5, x square plus y square equal to 111, and then it says the value of x cube plus y cube is equal to what? So if you look by just ordinary looking at it, there seems to be no relationship between whatever is given over here and how to find out x cube plus y cube. Okay. So there's a way to look at it, but you need to know your identities for that. And I'll show you how to get it. Okay. First of all, we are given x plus y equal to 5. So let us begin with that. So we are getting x plus y equal to 5. This is given. Next, what we do is squaring on both sides. Squaring on both sides. Let's see what is given. So this we can write as x plus y whole square plus equal to 5 whole square. So that is what it means by squaring on both sides. Okay. Now next thing is we expand this thing. What is? So this is a plus b whole square. You need to know a plus b whole square identity. So that will give us x square plus 2 y square, or you can even write 2xy, up to you. I'll write it x plus y, x square plus y square plus 2xy equal to 25. 5 square is 25. Okay, done. Now next, okay, now we have been given in this another thing. We are given x square plus y square is equal to 111. So I'm going to substitute this x square plus y square with that 111. I'm going to put 1 here, 2xy equal to 25. Why? Because we are given x square plus y square equal to 111. Okay, done. Now next thing what I'll do is I'll take this 111 and I'll take it on that side. When I do that, the sign changes of 111. It will become negative. Now be careful over here. Okay, because the sign of the greater number is negative. So don't write anything in positive and get your answer is wrong. Okay, so 25 minus 111 will give us minus 86. Remember, not positive 86, negative 86. And we write here 2xy. Okay, next. This is 2xy, right? So 2 into xy. So 2 if we take on the other side, it gets divided. Xy we get as minus 86 by 2. And so we will get xy equal to minus 43. Okay, so now we've got xy equal to minus 43. Now let's move further. Now we are asked what is the value of x cube plus y cube. Now this is same as a cube plus b cube. You should know this identity. So I'll write it and I'll expand it also. X cube plus y cube equal to, this can be written as x plus y into x square minus xy plus y square. Okay. So x plus y into x square minus xy plus y square. Okay. Now, we have been given x plus y equal to 5 right at the beginning. Okay. So, I'm going to write x cube plus y cube equal to 5. Okay. Because we are given x plus y equal to 5. In brackets, I'll put it. Then, we were also given x square plus y square equal to 111. So, I'm going to put it as 111. Okay. And minus xy. Now, over here, if you notice, we were given xy equal to minus 43. So, if I take the minus side on the other side, it will become minus xy equal to positive 43. Okay. And here we have got minus xy. So, I'm going to change this with plus 43. Okay. Now, going to add what is there inside the bracket first. So, x cube plus y cube equal to 5 into, so 111 plus 43 will give me 154. Now, write this first and then we multiply 5 into 154. That will give us 770 as the answer. So, this is the value of x cube plus y cube. This is how you solve this problem. And let's see if we have the answer here. So, D is our correct choice. Let's move to question number 14. Okay. Question number 14 says, if the difference between two supplementary angles is 60 degrees, okay, then the smaller angle is what? Okay. So, first thing first, what we know about supplementary angles? Supplementary angle says that sum of two angles is equal to 180 degrees. So, if you take x and y as the two angles, so we can say x plus y equal to 180 degrees. Okay. So, this is sum of supplementary angles. Okay. Which is always equal to 180 degrees. But what we have been given in our question is the difference between two supplementary angles is 60 degree. So, that means the difference x minus y equal to 60 degrees. Okay. Now, we are asked to find the smaller angle. So, what we do over here is we just like how we do, we'll just add them up. Okay, over here. So, x plus x gives us 2x. So, this x plus x. Okay, plus y minus y becomes 0. You don't write 0, you just put a line over here. Equal to 180 plus 60 will give us 240 degrees. Okay, so that means we have 2x equal to 240. 2x means 2 into x. If you take 2 on the other side, it will become division. So, 240 upon 2. 2 ones are 2, 2 twos are 4 and 2 zeros are 0. So, which means x is equal to 120 degrees. Okay, but we are not asked to find x. We are asked to find the smallest angle. Okay, smaller angle in this. So, if we'll put this x in any one, we can put it in the first equation, second equations, and mark this as equation 1, equation 2. We'll put substitute x equal to 120 degrees in equation, let's say 1. Okay. So, so equation 1 is what? X plus y equal to 180. So, in place of x, I'm going to substitute 120 degrees because we got the value of x plus y equal to 180 degrees. When I take 120 degrees on the other side, it will become negative. So, 180 degrees minus 120 degrees, and that gives us y equal to 60 degrees. Now, I told you these are two angles, x and y. X is 120 degrees, y is 60 degrees. That means y is a smaller angle, and that is 60 degree. Okay, so have a look here. We have that here, and so our correct choice is B. So, B is our correct choice. Moving on to question number 15. Okay. Question number 15 says, if two exterior angles of a triangle are 110 degrees and 120 degrees, then the measure of the third exterior angle is what? Okay. Now, We know in case of a triangle that you will come across this thing where it says the sum of all exterior angles. Okay, the sum of all exterior angles of triangle equal to 360 degrees. So which means we'll say exterior angle 1 plus exterior angle 2 plus exterior angle 3 equal to 360 degrees. Okay. Now we are given two exterior angles, so we'll take this as 110 and this one is 122 degree, 120 degrees. Exterior angle 1 will take 110, exterior angle 2 will take 120 degrees, and we need to find the third one, the exterior angle 3, and that is it. All of this sum is equal to 360 degrees. 110 plus 120 gives us 230 degrees, and if we take it on the other side, the sign will change from positive to negative, and it will become 360 degrees minus 230 degrees. 360 degrees minus 230 degrees will give us 130 degrees. Let's see if it is there in our choice. Okay, so C is the correct answer. Okay, here you go. Question number 16. One side of a parallelogram is 2.4 centimeters and the other side is 3.2 times that of the first side. Then the perimeter of the parallelogram is what? Okay, so let's look. So we are given side 1 of the parallelogram is equal to 2.4 centimeters, and we are set side 2 is 3.2 times of the first side. Okay, of side 1. So 3.2 into side 1 is what? 2.4. So 2 ones are 2, 2 twos are 4. So 3 into 1.2, so that is gives us 3.6 centimeters. Okay, so side 2 is that. Now we have to find the perimeter of the parallelogram. So this is the parallelogram. Okay, and the perimeter is the sum of all the sides. So if this side is 2.4, okay, we'll take this side as 3.6. This side is 2.4, and opposite sides of the parallelogram are equal. So this will be also 2.4 and this will be also 3.6. So perimeter is the sum of all the sides. So perimeter of parallelogram will be equal to 3.6 plus 2.4 plus 3.6 plus 2.4. That will give us what? 3 plus 2 is 5.6 plus 0.4 is 1. So that means this is 6. 6 plus 6, and that will give us 12 centimeters. Let us look if we have that in our answer. Yes. So C is the correct choice. Question number 17. If A is an acute angle and sine square A plus sine square 65 degrees equal to 1, then the value of A is one of these. Let's just write down what is given. So it says sine square A plus sine square 65 degrees equal to 1. And we have to find out the value of 1. We know that sine square A plus cos square A equal to 1. Okay. If we compare this equation 1 and equation 2, we see that we have sine square A plus, but instead of cos square A, we have sine square 65 degrees. So that means cos square A should be equal to sine square 65. So we say from 1 and 2, we get cos square A is equal to sine square 65 degrees. Okay. Now, cos square A can be written as sine square 90 degrees minus A equal to sine square 65 degrees. Why? Because it's a complementary angle. So we say sine of 90 degrees minus A will be equal to cos A. So same way over here, this is square over here, it will be an extra thing. Okay, so we have sine square over here, we have sine square over here, we get rid of them and we get 90 degrees minus A equal to 65 degrees. Now we'll switch sides, we'll bring A minus A on the right hand side and we'll take 65 degrees on the left hand side. So when minus A comes on this side, it will become plus, and when 65 degrees, which is positive, goes on the left hand side, it will become minus. And we'll get something like this: A equal to 90 degrees minus 65 degrees. Yet A equal to 25 degrees. Okay, that is our answer. We'll see if our answer is there. Yes, it is there. Option C. Repeat over here. C. Move to question number 18. Question number 18 is the value of 1 minus tan square 45 degrees upon 1 plus tan square 45 degrees is the same as the value of, we'll have a look. Okay. So we write over here 1 minus tan square 45 degrees upon 1 plus tan square 45 degrees. Okay. So tan 45 is what? 1. Okay. So 1 whole square, and here also 1 whole square. This will become 1 minus 1 and this will become 1 plus 1. 1 minus 1 is 0 and 1 plus 1 is 2. But 0 upon anything is 0. Okay. So we have been told over here, asked over here, whether it is the same value of one of these. So sine of 0 is 0. Cos of 0 is 1. Tan of 45 is 1. And tan of 90 would be sine of 90 upon cos of 90. Okay, that would be not defined. So sine of 0 equal to 0 matches with this value which we have got, 0. So the correct answer would be sine 0 degrees. So correct answer is A, is our correct choice. Question number 19 is assertion and reason. So it says directions in question number 19 and 20. A statement of assertions is followed by a statement of reason R. Select the correct option from the following. Okay, so we have been given 4 of them, but let's have a look at question number 19 first. Let's do the working and see if we and then match with what we have got over here. So 19 says the remainder when p of x equal to x cube minus 2x square plus 3x is divided by 2x plus 1 is 9 upon 8. So and the reason over here is if a polynomial p of x is divided by ax minus b, the remainder is the value of p of x at x equal to b upon a. So let's solve this one first, which says the remainder when p of x is divided. So we have to find out whether the remainder when this polynomial is divided by this polynomial, whether we get the remainder as 9 upon 8. Okay, so we'll write that over here 19 and take p of x over here equal to x cube minus 2x square plus 3x. Let's us take g of x equal to 2x plus 1 over here. Okay, now further we'll take g of x equal to 0, and that means 2x plus 1 equal to 0, which will become x equal to minus 1 upon 2. Okay, now we'll put this minus 1 upon 2 in this polynomial wherever there is x. Okay, and we'll see what happens. Minus 1 upon 2, p of minus 1 upon 2 equal to minus 1 upon 2 whole, the cube, minus 2 into minus 1 upon 2 whole square, and plus 3 into minus 1 upon 2. So this will become minus 1 upon 8. Okay. Then this will be minus 2 into minus half into minus half will give us positive 1 upon 4. 3 into minus 1 upon 2 will give us minus 3 upon 2. Further, minus 1 upon 8, 2 and the 2 2s are 4, and we will get minus half over here. This will be minus 3 upon 2. Okay. Next. So over here, if we have a look, if we take the LCM over here, so this will be 2 comma 2 comma 8. We'll get 2 1s are 2, 1 are 2, and 2 4s are 8. This will be 2 1 1 2, 2s are 4. Again 2 1 comma 1 comma 1. Okay. So we get 2 2s are 4, 4 2s are 8. That should be the denominator over here. So let us make this equal. So 1 upon 8, no change in this, but this has to become 8. So we multiply this by 4, and this also has to be balanced on top by 4. Same thing over here, multiply by 4 in the numerator as well as denominator. All this we are doing because we want the denominator is the same. Okay, without which we cannot add or subtract. So now we'll be having a common denominator, and then so that we balance, so that it should not look out of order, we balance it by multiplying the numerator with the same number. Okay, in both the cases. So minus 1 upon 8 minus 1 into 4 is 4, 2 into 4 is 8, minus 3 into 4 is 12, 2 into 4 is 8. Minus 1 minus 4 minus 12 whole thing upon 8. Okay. Now this, if we add minus 1 minus 4 is minus 5, minus 5 minus 12 is minus 17. So we get minus 17 upon 8. Now we were given over here what? We were given 9 upon 8. So clearly assertion in this case is false. So our assertion which was given is false. Okay. Let's look further because it's a combination. So we need to see the assertion and also the reason. Now the reason we are given here, if a polynomial p of x is divided by a of x, ax minus b, the remainder is the value of p of x at x equal to b upon a. So similar strategy will apply over here. So we have been given p of x. We're not given anything. Just p of x is divided by a. So we'll take 20 here. Sorry, 19 only. We'll take g of x equal to ax minus b. I'll take g of x equal to 0. That will be equal to ax minus b. And then this will become x equal to, minus will go on the other side, become positive, b upon a. And this is what we'll get. And what we are given over here, x equal to b upon a. So x equal to b upon a, that's what we got. That means our reason is true. So assertion is false, reason is true. Okay, now we have to search in our choices whether assertion is true or reason is false. Sorry, assertion is false, reason is true. Here assertion is false but reason is true. So D is the correct option. So we put D over here and we'll move to question number 20. Coming to the last question of this section, section A, it says assertion is in triangle ABC and triangle PQR, if AB is equal to PQ, AC is equal to PR, and angle BAC equal to angle PQR, then triangle ABC is congruent to triangle PQR. That's right. We're given triangle ABC. Okay. So I'll draw two triangles ABC and we have triangle PQR. So PQR. Okay. Now it says that AB is equal to PQ. Okay. It says AC is equal to PR. All right. And it says angle BAC is equal to angle PQR over here. Okay. And it says triangle ABC is congruent to triangle PQR. So yes, triangle ABC can be congruent to triangle PQR because we have got two sides equal to each other. Okay, we can show that two sides are equal to each other in both these triangles, and one angle of each of them is equal to each other. So yes, it's possible to show that triangle ABC is congruent to triangle PQR. So our assertion is true. Assertion is true. What about our reason? Both triangles are congruent by a triple S congruence rule. No, because we are told about only two sides, but there is also an angle. So it should actually become SAS. Okay. But for S triple S, it should have been showing BC equal to QR, which is not showing. So our reason is false. Okay. It is not by triple S congruence. So you can say reason is false. Let us look in our choice. Assertion in this case is true, but reason is false. So it is, in this case, the answer is C. Okay. So with this, we come to an end of section A, which was for 20 marks. Okay. I hope you found this useful, how the solving has been done. And what I will be doing, will be putting up videos section by section. Okay. And then there will be a combined video. The combined video would probably be only for the members only. If you would like to become a member of this channel, then you can click the join button and pay just a fee of 59 rupees for a month, and you can always cancel the membership whenever you don't want it. Okay. So under the membership, you will have videos which have been done in the past. Okay, certain videos of the past. And also I will be doing videos which will be exclusively for the members as well. So you can have a look and see if you would like to join the membership of this channel. Also, there's a WhatsApp channel. You can start following that channel for any updates that will be coming up leading up to your examination, not just semester 1 but also semester 2 later on, and whatever updates with respect to circulars will be coming. The link to the membership channel as well as to the WhatsApp channel you will be able to find in the description box below. Let me know how you found this video. If you like this, watch this video, please hit the like button, share this video with your friends as well as your classmates, and keep watching. I will be coming up with other sections of this model paper. Thank you for watching, and please do subscribe to the channel. It really helps. Thank you. Keep watching. Continuing with section B, it's for 2 marks each. Question number 21. Represent 7 root 7.3 on the number line. Okay. So for that, first you draw a line. So for those of you who do not know how to construct it, this is how it needs to be done. So that is a line here. Okay, that should be more than enough. Okay. So first thing is I'll draw a line which is 7.3. So 1, 2, 3. So 7.3. Okay. And I'm going to extend that line further as well. So yeah, mark this as 7.3 over here. 1, 2, 3 here. Okay. And this will become our 0, and I'll mark it as B. I'm going to mark this as A. Okay. Then 1 centimeter from here, let me mark all of them. So there's 1 here, 1 here. So this will become a 1, 2, 3, and let's take 4. That's more than enough. This is 1, 2, 3, 4. Okay. And let's say this is x. Okay. Now from A to B is 7.3 centimeter. That's what I have taken. Okay. Now next thing is we have to draw a perpendicular bisector, and I'll mark this as C. To draw a perpendicular bisector to AC. So which means we have to take a measurement which is more than half of AC. So no, so 7.3 plus 1, 8.3. You can either take a measurement using a ruler or just approximately take what you feel would be half of this. So I've just taken approximately, which I feel is sufficiently more than half of AC to draw the perpendicular. So draw a cut and arc here, and a cut and arc down as well, if you can see it here. And I'm going to do the same from A as well. Another perpendicular bisect, another arc. And now we can draw a line passing through these two intersections, one here and one here. So we'll cross a line and draw a big line passing through both of them. Okay, something like this. Okay, here you go. Okay, now that we have got our perpendicular bisector, okay, I will mark this point. You can mark this, let's say, as O. Okay, and from A to O you can measure. Okay, and draw a semicircle. Okay, that should extend from A to C, like this. Okay, there you go. Okay, A to C. Then draw a perpendicular from B, right, or 0. You know how we draw the perpendicular. So something like this. Then from here we'll cut a line here, arc, sorry. From here we'll cut another arc here, as well as one on top, like this. And using the same measurement, we keep the point here and we cut another arc here. And then we keep, see where the two arcs intersect. From there to 0, we draw a line like this. That becomes our perpendicular. Okay. Now, you see where this line, perpendicular line needs this arc. That is what we need to measure using our compass. This is what I'm saying. From here to here. Okay, you see, this is what I'm, okay, and then we keep it on 0. Okay, make sure you arc. Okay, and we draw only arc. Now where this arc cuts the line, this is your root 7.3. Okay, so that's how you draw. I'll once again go through the steps in case if you found it confusing. First thing, we just draw a line. Okay, and on that line we mark 7.3. Now where we mark 7.3, okay, the measurement is 7.3. One end we mark as A, other end we mark as 0, and below that we write as B. Then we continue marking measurements of 1, 2, 3, 4 on the ruler with the help of the ruler. 1, 2, 3, 4, and under 1 we write as C. The next step is to take construct a perpendicular bisector to AC, and this is what I get. Okay, then using this as a center, we draw a semicircle, so it extends from A to C. Okay, now from 0 we draw a perpendicular. Okay, and where this perpendicular intersects with this arc that we had drawn, which is over here, okay, we measure that, and on measuring that thing, we keep the compass over here, the pointer, and draw another arc. Now where the arc intersects this particular line, that becomes our root 7.3. That's how we construct root 7.3. Question number 22. Express 0.54 bar in the form P upon Q, where P and Q are integers and Q is not equal to 0. Okay. So we have got 0.54, which we need to express in the form of P upon Q. So we say let 0, so the 54, or you can say let x equal to 0.54 bar, which means we can write x equal to 0.5454. Okay, because it is recurring. This bar refers to mean those numbers are repeating. Okay, now we can take this as 1 and we can say now there are two numbers recurring together, so we need to multiply both sides by 100. Okay, so we say multiply 1 by 100 on both sides. So that will be 100 into x equal to 100 into 0.5454. Okay. Now when we multiply 100 into x gives us 100x, and 100 into 0.5454, this, since there are two zeros, the decimal point will also move 2 places to the right and will give us 54.54, and we'll mark this as 2. Our next step is subtracting 1 from 2. So we say 2 minus 1. So we'll get 100x minus x on here, and 54.54 minus 0.54. Okay, no need of showing 0.5454. The whole idea is to get something like P upon Q and eliminate the decimal places. So 100 minus 1 gives us 99x. 54 minus this is you have 0.54. Okay, so that means we get 54 over here. It will be 99x means 99 into x, can bring 99 on the other side, it will become 54 upon 99. That goes in 3 times table. 3 3s are 9, 3 3s are 9, 3 1s are 3, 3 8s are 24, which means x is equal to 18 upon 33. Can say therefore x is, we have said, is equal to here 0.54. So that means we can write 0.54 is equal to 18 upon 33. So this is in the form P upon Q, where Q is not equal to 0. Next, we have been asked factorize the following quadratic polynomial by splitting the middle term. We are given a choice of this and this. We are going to solve both of them. First one is 4x square minus 11x plus 6. I'll write as A, 4x square minus 11x plus 6. Okay, so we got to factorize this. So we have got 4 and 6. 4 6 are 24. So 24 can be split into 4 6 are 24, 8 3s are 24, 12 2s are 24, 24 into 1. But what we have in between is minus 11x, and in the constant term is positive, which means the two factors have got to be negative. Negative into negative gives us positive, and that is why the two terms have got to be negative over here. So two negative terms which when added gives you 11. That is how we need to find out. So there's only one, that is 8 and 3. Minus 8 and minus 3 will give us minus 11, but minus 8 into minus 3 will give us plus, okay, 24. So we say equal to 4x square minus 8x minus 3x plus 6. So in this two we get 4x common. So 4x remember, which leaves only is x over here, and here there will be minus 2 left. Here we'll take minus 3 common, and instead of minus we'll be left with only x, and since you have taken minus sign outside, this will become minus and this will become 2. And now we can say x minus 2 into what is left, 4x minus 3. So these are the factors of this particular quadratic polynomial. Okay, we do the next one, that is b, and that is 6x square plus 7x minus 5. So 6x square plus 7x minus 5. 6 5s are 30. 30 can be split into 5 6 are 30, 10 3s are 30, 15 into 2 is 30, 30 into 1 is 30. So middle term is positive and the constant term is negative, which means one is going to be positive and one is going to be negative, the factors I'm talking about. And the larger number is going to be positive. That is why you have a positive sign over here. So one has to be plus, one has to be minus. So I see 10 and 3. Positive 10 minus 3 gives us positive 7, and 10 into 3 will give us 30 and minus 30. So 6x square can say plus 10x minus 3x minus 5 equal to sign, do not forget. So here we have, I can take 2x common. 2x, what will be left here is 3x plus 5. Okay, since 2x is out from here, only 5 remains. Here I can take minus sign common, minus 1 I can take because there is nothing else common. If I take minus sign out, that means both these become positive. It become 3x plus 5. So we write 3x plus 5 as one factor and the other factor will be 2x minus 1. Okay, this is how we solve this. Next question, question 24. Evaluate 5 raised to 3 upon 4, 25 raised to minus 1 upon 2 divided by 125 raised to 3 upon 4. The moment I see this, I see that they are all multiples of 5. If you are not sure, then you can at least factorize this one to find out. Like 125, if we factorize, it will go in 5 times table because the unit digits end with 5. 5 2s are 10, 5 5s are 25, 5 5s are 25. Here you go. So 5 raised to 3 gives us 125 and 5 raised to 2 will give us 25. 5 5 are 25. So I'll make sure that all our bases are 5 over here. So we say equal to, keep this the way it is, 5 raised to 3 upon 4 into 5 raised to 2 to minus 1 upon 2 divided by 5 raised to 3 into 3 upon 4. Okay. Now, next thing is, this is 2 into minus 1 upon 2. That means this 2 and this 2 will cancel. Well, once again write it this way, into, this will be now 5 raised to minus 1. Then we have over here, I'll leave this the way it is. Okay, you can, that's fine. You cancel this minus 1, divide by 5 raised to 3 into 3 is 9 upon 4. The first thing is we add this. So powers are the same. So this is in this form, a raised to m into a raised to n. So a raised to m plus n. This is the rule. Okay, exponential rule. So we are going to apply this to this. 5 raised to 3 upon 4 minus 1, that is minus 1 divided by 5 raised to 9 upon 4. So I'm going to take this separately. This will become, we take the LCM, 4 1s are 4. So we got 3 minus 4 upon 4 divided by 5 raised to 9 by 4. This will become 5 raised to minus 1 upon 4, sign of the greater number, divided by 5 raised to 9 by 4. Now you see same basis but division. So this is in this form, a raised to m divided by a raised to n gives us, we can write it as a raised to m minus n. I'm going to do the same thing over here, 5 raised to minus 1 upon 4 minus 9 upon 4. Since the denominators are the same here, it's easy for us to calculate. Minus 1 minus 10 upon 4. Sorry, minus 9 it is. Minus 1 minus 9 upon 4. This will give us 5 raised to minus 10 upon 4. 2 5s are 10, 2 2s are 4. And we get 5 raised to minus 5 upon 2. That is the answer. Question 25 says, find the value of k if x plus root 2 is a factor of p of x equal to 3 root 2 x square plus 5x plus root 2. So we already told x plus root 2 is a factor of p of x, which means we can substitute minus 2 inside this. How you get minus 2? I'll show you. Okay, first we say p of x equal to 3 root 2 x square plus 5x plus root 2. Okay, this has been given to us. But I feel there is a mistake over here. This is not 2 because we are asked to find k. So there is no k over here, and I believe this has got to be k. I'm going to change this to k, which is given in your model paper like that. I'm going to change this to k. Hopefully that is k. And I'm going to solve for this. Now we are given that x plus root 2 is a factor of p of x, which means that what is said, if p of x equal to 0, that means x plus root 2 equal to 0, and that means x will become equal to minus root 2. And so we'll, in place of x, we'll substitute minus root 2. So I say p of minus root 2 equal to 3 root 2. Instead of x square, we'll put root 2 whole square plus 5 root 2. Sorry, minus it is. Minus, because this is minus. And here also minus 1 will come. Plus k. Okay. And p of minus root 2 is 0. So that will become 0. So this will be 3 root 2 minus 2 minus root 2 whole square is 2. 5 into minus root 2 gives us minus 5 root 2 plus k. Okay. And this will become again 0. 2 into 3 is 6. So 6 root 2 minus 5 root 2 plus k. Okay. Then this will become, write this way now, k 6 minus 5 is plus 1. So plus root 2 equal to 0. This is what we get. Take root 2 on this side and we'll get the value of k. So value of k is what? Minus root 2. Okay. So that is the answer if this is k. Question 26. In triangle XYZ, a line DE is drawn through X and parallel to YZ to form angles 4 and 5 as shown in the figure. Prove that angle 1, 2 and 3 equal to 180 degrees. Now don't just go and write that angle 1 plus 2 plus 3 is equal to 180 degrees, sum of all angles of a triangle. That is what you are asked to prove. Okay. So which means you have to use some other properties, particularly the ones that are mentioned in this. The main thing that is mentioned is this line is parallel to this line. And this falls actually under lines and angles and not triangles. Okay. So first thing that I can see over here is this 4, 1 and 5. They all fall in this straight line. And the how much is the degree of the straight line? 180 degrees. See, it forms a semicircle. So this plus this plus this, full thing forms 180 degrees. So that's what I'm going to write first. Angle 4 plus angle 1 plus angle 5 equal to 180 degrees. And I'm going to give it a reason saying that it is a straight line. Okay, the angle of a straight line is supplementary or 180 degrees. Next, we are given DE is parallel to YZ. This is given to us. So therefore, we can say that angle DXY is equal to angle XYZ. DXY is equal to angle XYZ. This angle is equal to this angle. How? So that means we can say angle, sorry, we'll write over here the reason first. Alternate interior angles. See, it forms a Z. So this angle is equal to this angle. So dxy is what? Angle 4. So therefore angle 4 is equal to angle xyz is 2. I'll mark this as 1 and I'm going to mark this as 2. Similarly, we can say also, you can say EXZ, angle EXZ is equal to angle XZY. XZY. How? Alternate interior angles. Okay, so reverse Z. This angle equal. So we can say therefore angle 5 is equal to angle 3, and we mark this as 3. Okay. Now what do we say? Substitute 2 and 3 in 1, which means what? In place of angle 4, which is over here, we'll put 2, angle 2. Angle 1 will keep it the way it is. And in place of angle 5, since angle 5 is equal to angle 3, we'll replace it with angle 3 over here. And all that is equal to what? 180 degrees. And that's what was asked. You were asked to prove angle 1 plus 2 plus 3 is equal to 180. So you say hence proved. This is how you solve this. Okay. Now I'm showing you a few additional steps. You can reduce the number of steps that are there if you are confident in solving this thing. Doesn't mean you have to solve it just this way. The small minor steps being shown over here. Okay, small steps do not carry marks. Certain steps do carry marks, but small steps. Now I'm breaking it down for those who would not be able to understand how you get those how do you get that particular step, or how does the next step arrive. Question 27. There's a choice here. We're going to solve both those choices. Expand using suitable identity 5a minus 7b plus 3c whole square. Okay. So first we need to write down the identity. The identity is a plus b plus c whole square equal to a square plus b square plus c square equal to 2ab plus 2bc plus 2ca or ac, whatever. Okay. So this is the identity we need to use. Now we are asked to expand 5a minus 7b plus 3c whole square. Okay. So this we can write as a square. So this will be 5a square plus minus 7b whole square plus 3c whole square. You see how I've written here? Irrespective of the sign, I've written plus over here, but in the brackets I've put minus 7 because this is the formula. Okay, there's no minus over here. There's a plus b plus c it is. So using that formula, I've written it this way. Then plus 2 into a, which is 5a, into b, which is minus 7b, plus 2 into b, which is minus 7b, into c, which is 3c, plus, write it down over here, 2 into c, which is 3c, into a, which is 5a. Okay. Now we open the brackets. 5a whole square is 25a square, minus 7b whole square is plus 49b square, 3c whole square is plus 9c square. Now this will be 2 into 5 is 10, 10 into minus 7 is minus 70, minus 70 a b. 2 into take 2 into 3 is 6, 6 into 7 is 42, but this is minus sign is there, so minus 42 b c. 2 into 3 is 6, 6 into 5 is 30, plus 30 C, A. Fine. So this is how we solve it, and this is the end of it. This is what was asked. Okay. Now the next one, B, is given to us as 103 into 105. So 103 into 105, we can write this as 100 plus 3 into 100 plus 5. This is in this form: A plus B into A plus C. So this is our identity. So you get A square, then B plus C into A plus B into C. So we are going to expand this the same way. So we get A square plus B into C. So B and C is this. So 3 plus 5 it is. 3 plus 5 into A, which is 100, then plus B into C. So that's 3 into 5. And this will give us 100. So this will become, so you see 2 zeros are there. Squaring it will double the zeros. 5 plus 3 is 8. 8 into 100 is 800. Plus 15. 3 into 5 is 15. So we say 5 in the units place. So we write 5. 1 in the tens place. We write 1. There's nothing over here in the 100 place. 100 place is 8. There's 0 over here. So 8. Now there's nothing in the 1000 place. There is only 0 over here. And there is 10,000 place. There is 1. So 10815 or 10,815 is our answer. Question 28. In the adjoining figure, X and Y are midpoints of AC and BC. And AX is equal to CY. Prove that AC is equal to BC. This side is equal to this side. Run the figure over here. So I'll begin first with what we have been given, that X is the midpoint of AC and Y is the midpoint of BC. We say X is midpoint of AC and that is given. Therefore, AX becomes equal to XC. Mark this as 1. Also, we are given Y is the midpoint of BC. So we write Y is midpoint of BC. And we must say it is given. Therefore, BY is equal to YC. Therefore, BY is equal to YC. Mark this as 2. Okay. Also, we have been given that AX is equal to CY or YC. AX is equal to CY. We have been, this is given. We mark this as 3. Okay. Now, AX is equal to CX, but AX is also equal to CY. That makes CX equal to CY. And because CX is equal to CY, CX and CY is equal to BY. So CX also becomes equal to BY. Now I don't have to show here. Okay, I'll just say what it is first, then I'll explain to you. From 1, 2 and 3, we can say that AX equal to XC is equal to BY equal to YC. I'll mark this as 4. Now I'll explain to you how this becomes. See, AX is equal to XC, okay, from here, because it is a midpoint. And we are also told that AX is equal to CY. Now both XC and CY equal to AX. That makes XC equal to CY. Correct? From these two, we get this. Now, we know that CY, okay, is equal to, say over here, BY is equal to CY. How? Why? Because Y is a midpoint of BC. So, here we have told BY is equal to YC. BY is equal to YC. Right? Now, CY is equal to both XC and BY. They equal, right? So, that makes XC and BY equal to each other. XC is equal to BY, we can say. Okay. So, we have got over here ax equal xc is equal to cy. We got xc is equal to by. Okay, that makes cy equal to by. So they are all equal to each other that way. Okay, so now that they have all become equal to each other, we can say AC we can write as ax plus cy, correct? Sorry, ax plus cx, ax plus cx, AC. Okay, but ax is equal to what? Ax is equal to, you can say cy. Okay, and cx is equal to, we can say by, because they are all equal to each other, right? Cx is equal to by here. But cy and by is what? bc. So ac is equal to bc, hence proved. Okay, this is how we settle this thing. Question 29, we are told in the adjoining figure, PR is diagonal of parallelogram PQRS. And we are asked to show triangle PQR is congruent to triangle RSP. So PQR corresponding to RSP. I've drawn over here. So that is very easy to show. We can show this is equal to this because opposite sides of parallelogram are equal to each other. So this side is also equal to this side, and this is a common side. So by triple S, we can say that the three sides are, the two triangles are congruent to each other. So we take in triangle PQR and triangle RSP, you can say PQ is equal to RS, and we can say that side RQ, okay, RQ is equal to PS, opposite sides of a parallelogram, and PR is equal to RP, common side. Therefore, we can say triangle PQR is congruent to triangle RSP. That's how you, why, do not forget the reason, by triple S congruence rule. Question number 30, evaluate the following trigonometric expression using known numerical values of trigonometric ratios. 7 sine square 45 degrees plus 2 cos square 60 degrees. Write it down over. Question number 30. 7 sine square 45 degrees plus 2 cos square 60 degrees. 7 into sine of 45. So sine of 45 is 1 root 2, and because we have a square here, we'll put the square here, plus 2 cos of 60. Cos of 60 is half. Because the square, we'll put a square over here. So this will become 7 into 1 upon 2 plus 2 into 1 upon 2 whole square is 1 upon 4. So 2 ones are 2, 2 twos are 4, and what we get is 7 upon 2 from here plus 1 upon 2 from here. This becomes 8 upon 2, cancels, and we get 4 as the answer. Question 31. In the adjoining figure, line T is a transversal of lines L and M. This one, of lines N, L, M. Find the value of y for which lines L and M will be parallel to each other. So L is given parallel to M. We write down over here L parallel to M. Now if L is parallel to M, we can say these two angles are equal to each other because they become corresponding angles, and corresponding angles are equals. So we say 4y minus 10 is equal to 3y plus 20. Reason is they are corresponding angles. So bring 3y on this side to become negative. I'll take minus 10 on this side and it will become positive. So we get 4 minus 3, we get y equal to 20 plus 10 is 30. So y equal to 30 degrees is the answer. So with this we come to an end of section B. So those who are watching the video, if you have liked watching the video, please hit the like button. Share these videos with your friend as well as your classmates so they can also benefit like you. Please do subscribe to the channel because when you subscribe to the channel, it motivates me to do more videos. Also, whenever a new video is posted, you will get a notification about it. There's a WhatsApp channel that you may follow. The link to that is in the description box below. For any updates and for new videos, you will get information over there as well. Also, this channel has a membership. For those who would like to become members, there's a very small fee that you would need to pay in order to join this channel. So there's a join button. You can click on that join button. Okay, and any exclusive videos will be put up over there. So any video that you want on demand will be put up over there. Okay, and it will be exclusively for you. Plus all old videos also will be there. So if you want access to old videos, then you will be able to access them by joining the channel membership. Let's move further to section C, which is for 3 marks each. First question, 32. Simplify 4 plus root 13 upon 4 minus root 13 whole thing plus 4 minus root 13 upon 4 plus root 13. I'll write it down. Put section C, William. Okay. And question number 32, which is 4 plus root 13 whole thing upon 4 minus root 13 plus 4 minus root 13 whole thing upon 4 plus root 13. Next, what we do is we have to take the LCM. So we basically just cross multiply. We will get it. So this will become 4 plus root 13 whole square. Why whole square? Because this is also 4 plus root 13. This is also 4 plus root 2. So it becomes 4 plus root 13 whole square. Okay. Plus 4 minus root 13 to 4 minus root 13 also gives us 4 minus root 13 whole square. Whole thing upon, this is a minus b into a plus b. So that gives us a square minus b square. Okay. Now we simplify this further. So this would be a plus b whole square. So we a square plus b square plus 2 times a into b plus this is a minus b whole square. So a square, then plus b square minus 2 times a into b. Okay. Whole thing upon 4 square is 16 minus root 13 whole square is 13. 4 square is 16. Root 13 square is 13. Now we don't need to we have got the same thing if you notice here and here. One is the plus side, one is an opposite negative sign. Same value we'll get, so you can cancel out both of them. What will be left is just these two. So again we write 16 and again we write 13. Okay. Whole thing upon 16 minus 13 is 3. Then we add them. 16 plus 13 is 29. 29 plus 16 is 45 and 45 plus 13 is 58. So we get 58 upon 3, which is not divisible by 3. So we can leave it at this. This is the answer. Question 33 says divide the polynomial p of x, x cube plus 7x minus 12 by the polynomial g of x, x minus 1 and find the quotient and the remainder. I've already written this over here. So let's divide x minus 1 divided by x cube plus 7x minus 12. Okay, I've spaced it out because I know that there is no next power should have been a square, which is missing over here. That doesn't mean it's a mistake. It's just part of the division. Okay, so we'll see. Now we have x cube over here. We have x. The power is 1, power is 3, which means we need x cube over here. And if we need x cube over here, then we need to multiply x with x square, because 1 plus 2 gives us 3. Okay, the power. And the sign, whatever sign is here, will come here. That means whatever sign is there in the dividend, okay, will come over here. This is the divisor, this is the dividend, full thing. Or this is for us, this one alone is the dividend. So x cube plus, and do not forget about this. So this is not the only one there. The part of the polynomial is minus 1 also. So minus 1 into x square will give us minus x square. Now there is no x square over here. So we'll just write it and we'll bring it down. Now we change the sign so that we can cancel. So what is plus becomes minus, what is minus becomes plus. This goes and we don't put a 0, we just cancel. Bring down the x square and bring this plus 7x down like a normal division. Again, now we need x square over here and we have got x. So power is 1, we need 2. So to do that, we'll multiply x with another x. X into x gives us x square. Minus 1 into x will give us minus x. We change the sign to get rid of this x square, and this also will change sign to become plus. Cancel. 7 plus 1 gives us 8x. Bring that minus 12 down. Now, we've got x over here, we've got x. Power is the same, but the coefficient of x is 1 over here, coefficient of x is 8 over here. And we need 8x over here. So for that, we multiply x with a positive 8 and we will get 8x. Minus 1 with positive 8 gives us minus 8. We change the sign throughout. This gets cancelled. Minus 12 plus 4 will give us minus 4. Okay. So the division is done. It will not proceed any further. Okay. Because the highest power was 1, here it is 0. So we write our quotient and the remainder because that's what we are asked. So quotient is equal to what is on top, x square plus x plus 8 from here, and remainder is what remains after the division, minus 4. That is the answer. So this was 3 marks. Question 34. In the adjoining figure, AG is parallel to CH is parallel to EF. So they are all 3 lines are parallel to each other. Angle EAB equal to 90 degrees. Angle BEF, this angle is 65 degrees. We have to find angle CED, this angle. Angle EDC, which means this angle. And angle DBG. So this angle has to be found. Okay. Let's begin with what we have been given. So we have been given AG is parallel to CH is parallel to ES. We write there as given. Next, we can see that this line is parallel to this line we've given here. So that means if we look at FEB, it is equal to angle EBA because this forms a Z. So that means alternate interior angle. See this thing? This angle and this angle are equal. So we write over there as angle FEB is FEB is equal to angle EBA, that is equal to 65 degrees by alternate interior angle theorem. Okay, alternate interior angle theorem. Now, EBA is nothing but DBA. This is the same angle. So this implies angle DBA equal to 65 degrees. Now, angle DBA plus angle DBG equal to 180 degrees. This angle plus this angle is 180 degrees. How? By linear pair axiom. See this line standing on this line. Okay, so this plus this equal to 180 degrees. So we say linear pair axiom. DBA is 65 degrees. And DBG is what we need to find out. So angle DBG will become equal to 180 degrees minus 65 degrees, and that comes to 115 degrees. So we were asked to find angle DBG. So we found that first. Okay. Now we'll take this entire triangle EBA. So we say in triangle EBA, angle EBA plus angle BAE plus angle AEB equal to 180 degrees as sum of all angles of a triangle. Which one? This angle plus this angle plus this angle. Okay, this part of this big triangle. This plus this is equal to 180 degrees. Now, EBA we have got a 65 degrees. PAE, this is actually a right angle triangle. So it's marked over there. I didn't mark it in the figure. Here you go. So that's 90 degrees. It's given. So which means that we need to find angle AEB. So we can write angle AEB equal to 180 degrees minus 90 plus 65 comes to 155 degrees. When I take it on the right hand side, it becomes negative. And 180 degrees minus 155 degrees will give me 25 degrees. Okay. So AEB is 25. Now we can write AEB as CED because it's the same angle, right? So we can say this implies angle CED equal to 25 degrees. And we are asked for CED. So CED is done, DBG is done, ADC is done. That is ADC, EDC, this one angle. Okay. Now we know that this line is parallel to this line, right? So if you look at this, it forms a Z, which means alternate interior angle. That means EDC is equal to 65 degrees. So you can say angle EDC is equal to angle CED. Sorry, not CED, FED. FED equal to 65 degrees. Alternate interior angles. Okay, so with that we are done. We got angle EDC as well. So 1 mark, 1 mark, 1 mark, 3 marks total. That's how you solve this one. Question number 34 has a choice. So one we have already solved. Solve the other one now. In the adjoining figure, XY is parallel to ZW. Angle ZXY. ZXY equal to 90 degrees. Angle YZW is 35 degrees. Angle WYZ is 50 degrees. We have to find angle XZY, which is this one. We have to find XYZ, which is this one. which is this angle, and we need to find YWU, so this particular angle. Okay, so what I see directly is, if we look at this particular triangle YZW, there is this angle and this angle given. This angle plus this angle should be equal to this angle as an exterior angle of this particular triangle. Okay, so using the external angle theorem, we can say this angle is equal to this plus this angle. We will do just that. So we mention over there that first we mentioned that okay, we'll start with that triangle. In triangle ZX, not ZXY, we'll start with this particular triangle YWZ. We can say angle WZY plus angle WYZ equal to YWU, angle YWU, as external angle theorem. Angle WZY is 35 degrees. Angle WYZ is 50 degrees. That is equal to angle YWU. So therefore you can say angle YWU is equal to 85 degrees. Okay, so that is done. We found angle YWU, okay, because that's what was mentioned here. Now we'll go the other direction. So we are told that XY is parallel to ZW. So XY parallel to ZW, which is given. So if we look at this, we can say this angle is equal to this angle. So it forms Z, alternate interior angles, because this line is parallel to this line. We can say therefore angle XYZ is equal to angle YZW, which is equal to 35 degrees. I say alternate interior angle theorem. Okay, so we needed XYZ, so we've got XYZ as well. Now XZY remains. So we've got this angle as 35 degrees, and we know this is 90 degrees is given to us. So we say in triangle XYZ, angle XYZ plus angle YZ, ZXY, you can say ZXY plus angle YXZY. So XZY equal to 180 degrees, sum of all angles of triangle. Okay, so angle XYZ we've got as 35 degrees. Then angle ZXY is 90 degrees given to us. We have to find angle XZY, and whole thing is equal to 180 degrees. So we can say angle XZY equal to 180 degrees minus 90 plus 35 is 125 degrees, which when is brought on the right hand side becomes negative. So this will give us angle XZY equal to 55 degrees. Okay, so in this way we solve for all three angles, 1 mark each to find out each. Okay, so done with this. Question number 35. It says given a triangle PQR is an isosceles triangle such that PQ is equal to PR and ray PS is the bisector of angle QPR. Prove that angle Q is equal to angle R. So in order to prove angle Q is equal to angle R, we need to show these two triangles are congruent to each other. So we'll do that. So just written down PQ is equal to PR. Okay, so which means we can say therefore angle PRS is equal to angle PQS. You mark it as 1. That means this angle is equal to this angle. And why is it so? Because angles opposite to equal sides are equal. Okay. Then we take in triangle PSQ and triangle PSR. PSQ and PSR. Okay. We can say PQ is equal to PR, which is given to us. Then angle PRS is equal to angle PQS, which is from here. So we say from 1. And we can say that angle SPQ is equal to angle SPR. Why? Because SP bisects angle QPR, which is given to us. Okay, so this angle bisects this particular angle. So this angle is equal to this angle. So that's what we say. SPQ is equal to angle SPR. So we've got one side and two angles equal. So this angle, side, angle. So therefore we can say triangle. We can say once again PSQ is congruent to triangle PSR by ASA congruence rule. Okay, and once these two triangles are congruent, we can then say that therefore angle PQS is equal to angle PRS by CPCT. PQS is equal to angle PRS. This implies angle Q is equal to angle R. Hence, proved. Okay, this is how we solve this problem. Question 36 has got two choices. We'll solve both of them. First one, in the adjoining figure, BA is perpendicular to AC and ED is perpendicular to DF, such that AB is equal to DE and BF is equal to EC. Okay, we are asked to show that DF is equal to AC. Now, if you want to show DF is equal to AC, we'll have to prove that these two triangles are congruent to each other. So let's see how we can do this. Okay, so we begin with first what we have been given. Okay, that we'll start with triangle CAB. Okay, proof in triangle CAB. Where is CAB? CAB is over here. Now we can write CF is equal to CB minus FB. Okay, what have I done? CF, this region I can write as, now we are talking only about this triangle. Okay, so CF we can write as CB minus FB. Only I'm interested only in this part, CF, and we'll come to know why I'm interested in this part. So this part is nothing but this whole thing minus this thing will give us this thing in this particular triangle only. We mark this as 1. Okay. Similarly, we can say in triangle EDF of this comma, we can say that CF is equal to EF minus EC, and we mark this as 2. So now we are looking at this triangle. Before we were looking at this triangle, now we are looking only at this triangle, and again same length I've taken CF, but this time CF is this full length EF minus EC. Remember, CF this time is EF minus EC, for this particular triangle. Okay, so we've got 1 and we have got 2, and you can say from 1 and 2 we can say that CB minus FB from here is equal to EF minus EC. Why we can say that? Because both of them are equal to CF. So they are equal to each other, we can say. Okay. Now, we have been given that we have it given over here. So, but we can say BF is equal to EC, which is given to us. What is BF and EC? Here, BF and EC. Okay, so they are on either side, so which means they'll cancel out each other, and we can therefore we can say CB is equal to EF. Okay, therefore we can say CB is equal to EF, and we can use that as the third point over there. Now, where is CB over here? CB is here, EF is here, which means now we have this side of this triangle equal to this side of this triangle, which is helpful for us if we are going to show that these two triangles are congruent to each other. See, we already got this side is equal to this side. We know that these two angles are perpendicular, that means right angles 90 degrees. Okay, and now we have got this side equal to this side of these two triangles. So we have got three things to show that these two triangles are congruent to each other, and once we show that these two triangles are congruent to each other, then we can say the sides that we need, that is DF equal to AC, okay, as CPCT. So let's do that. So we begin with the triangle that we need first. In triangle BAC and triangle, you can say EDF. Okay, which other triangles? BAC and EDF. Okay, we can say now that angle BAC is equal to EDF, which is equal to 90 degrees, and now this is given to us. Okay, next we are also given that AB here, AB is equal to DE. This is also given to us, and we have shown over here that BC is equal to EF, which is from 3. Okay, so we have got one angle and we have got two sides. So we'll see which other angles are. We've got this side, this side, and one angle. So we have we have got a angle, we've got a side, and we've got a side. So angles, side angle, no, not a side angle. Yeah. Okay. So here, if you look, this is the right angle. Then this is the hypotenuse. So the hypotenuse, both the hypotenuse of both of the triangles are equal to each other, and there is also a side, corresponding sides, which are equal to each other. So we can say, therefore, triangle BAC, I forgot to put a triangle here, BAC is congruent to triangle EDF by RHS congruence rule. Okay, and then we can say, therefore, AC is equal to DF by CPCT. Hence, proved. Okay, that's how you solve this one. The next option we have in the adjoining figure, it says angle BCD, this angle, is equal to angle ADC. So this angle, these two angles are equal to each other. And it says angle ACB. So this angle is equal to angle BDA. So this angle is equal to this angle, we are asked to prove AD is equal to BC. So if you want to prove AD is equal to BC, we'll have to show these two big triangles ACD is congruent to triangle BCD. If we can show that, then that means we will easily be able to show that AD is equal to BC as CPCT. So let's begin with what we have been given. So we are given, first of all, right, proof. We have been given that angle BCD is equal to angle ADC. I'll mark this as given. Also, we've been given angle ACB is equal to angle BDA, also given. Okay. Now, mark this as 1. Mark this as 2. And we'll say adding 1 and 2, we get angle BCD plus angle ACB equal to angle ADC plus angle BDA. So just added. Whatever was on the left hand side was added to get this. Whatever was on the right hand side was added to get this. That's all. Okay. Now, BCD and ACB. Where is BCB? BCD and ACB. ACB. So this angle plus this angle is nothing but this full angle. So angle ACD we can say. Angle ACD equal to angle ADC. So this angle plus angle BDA. BDA. This angle plus this angle is nothing but this full angle BDC. So we say equal to angle BDC. Okay. So we mark this as 3. So we've got angle ACD is equal to angle BDC. Okay. Now let's move further. So now we say in triangle ACD and triangle BDC, okay, can say angle ACD is equal to angle BDC from 3. Okay, we can also say that angle ADC is equal to angle BCD, which is given. And we can say CD is equal to DC, which is common side. And therefore, we can say triangle ACD is congruent to triangle BDC. And this would be by ASA congruence rule. Okay. And therefore, we can say AD is equal to BC by CPCT. Hence, proved. Okay. So basically what was done? We took two triangles ACD and ACD and BDC. In the previous part, we had shown this full angle is equal to this full angle. Oh, sorry. This full angle is equal to this full angle. Okay. Now in these two triangles, if you want to prove them congruent to each other, we have to show 3 things. So one thing was this full angle equal to this full angle. Fine. Next thing was this side is common to both these triangles. CD is equal to DC, whatever, or CD. And this particular angle is given equal to this angle. Now this angle belongs to this triangle VDC. And this angle belongs to this triangle, that is ACD. And so by angle side angle, we can say that these two triangles are congruent to each other. Okay, and therefore we can say that AD is equal to BC. Hence, proved. Question number 37. It says ABCD is a quadrilateral in which P, Q, R, S are midpoints of the sides AB, BC, CD and DA respectively. AC is a diagonal. If SR is equal to 5.2 centimeters and QR is equal to 6.4 centimeters. Find the length of AC, then find the length of PQ, and find the length of PS. Okay, so let us first begin with this and write down what we've got. So this is question number 37. Okay, let's say in triangle ADC, okay, triangle ADC, we can say that S and R are midpoints of AD and DC respectively. Okay, now this is given to us. We are told over here that S and R are midpoints. S is midpoint of AD, R is midpoint of CD or DC. Okay, so that's what we have mentioned over here. Okay, then we can say since they are midpoints of these two particular sides, we can say therefore by midpoint theorem, we can say SR is parallel to AC, and we can also say SR is equal to half of AC. And mark this as 1. Now, we can use the midpoint theorem in this particular triangle. See this triangle, ADC or DAC, whatever. In this particular triangle, we have got these two sides of the triangle, and these are the midpoints of those two sides. So the midpoint theorem says that if we have two sides of a triangle whose midpoints connect to each other, like join to each other, then the line that is formed by joining the midpoints of the two sides of this type of a triangle is half of the third side of the triangle and also parallel to the third side of the triangle. So SR is half of AC and SR is parallel to AC in that respect. Okay, so that is how we get this. Now moving further, we say in triangle ABC. Which triangle now? Now we are looking at A, B and C. We can say that P and Q are midpoints of AB and BC respectively. Again, this is given to us. Okay, have a look. We are told P and Q are midpoints of sides AB and BC respectively. Now this falls in this particular triangle. So what we applied here, and as a result of which we used the midpoint theorem and got SR parallel to AC, SR is half of AC. Same thing we can do with this. See this triangle? In this triangle, this is a midpoint of this side of the triangle, and this is a midpoint of this side of the triangle. Therefore, we can say by midpoint theorem that PQ is half of AC and PQ is also parallel to AC. Okay, so we write over here, therefore by midpoint theorem we can say PQ is parallel to AC and PQ is also half of AC. You mark this as 2. Now we can say from 1 and 2 we can say that SR parallel to AC parallel to PQ. Okay, mark this as 3. This will be 3. Mark this as 3. Okay, so SR is parallel to AC, but AC is parallel to PQ as well. So they all become parallel to each other. Now which lines are becoming parallel here? SR is becoming parallel to AC and AC is also parallel to PQ. So SR is parallel to AC parallel to PQ. In other words, SR is also parallel to PQ. Now this side in this forms a quadrilateral edge. PQRS forms a quadrilateral, and in this quadrilateral SR is parallel to PQ. And if that is the case, we can say that PQRS is a parallelogram, because for a parallelogram, one pair of opposite side should be parallel to each other and equal. We will also show that SR is equal to PQ. I'll show you how. See, we say SR is half of AC and PQ is also half of AC. In that regards, SR becomes equal to PQ. So we say and SR equal to PQ. We'll mark this as 4. Then we can say from 3 and 4 we get quadrilateral PQRS is a parallelogram. Okay, so we have proved that this quadrilateral forming inside the big quadrilateral PQRS is now a parallelogram, and we know the property of that opposite sides are equal to each other, which means PQ is equal to SR and PS is equal to QR. So that helps us to find the lengths of the other sides, and we will be also using the midpoint here. We'll also be able to find the length of AC this regards. Let's find out. Okay, so we are given SR is equal to 5.2 centimeters. Okay, but we know that SR is half of AC, correct? And we said this thing SR is half of AC in the first point. So we can say from 1. So this is 5.2 equal to half into AC. This 2, if we take it on the left hand side, it goes and multiplies with 5.2. So we will have AC equal to 2 into 5.2, and that will give us AC equal to 10.4 centimeters. So first thing we have to find out about AC, and we've got AC equal to 10.4. Also, we know that SR is equal to PQ. Okay, opposite side of parallelogram. My SR is equal to 5.2, so PQ also becomes equal to 5.2, and we can write this as 5.2 centimeters. Okay. Similarly, we are asked to find out about PS. We are given QR. We can write this as given. QR equal to 6.4 centimeters is given to us, and QR is equal to PS, opposite sides of parallelogram. So QR is how much? 6.4. So PS also becomes equal to 6.4 centimeters. Okay. So that's it. That solves all our questions. We were asked to find the value length of AC. We got 10.4. We were asked to find the length of PQ, which is 5.2 centimeters. And we were asked to find the length of PS, which is 6.4 centimeters. That solves this problem. Question number 38, it says in triangle LMN, angle M is 90 degrees, LM is 8 centimeters, MN is 15 centimeters. We need to find the length of LN, which we can find using Pythagoras theorem. And then we need to find the sine of N. This will be the angle, and tan of L. So this will be the angle. Let's find out. So here we go. So now if you need to find out Ln, then we need to use the Pythagoras theorem. Okay. So Pythagoras theorem says that the square of the longest side, which is the hypotenuse, is equal to the sum of the squares of the other two sides. So that means in right triangle, you can say LMN. Okay. Ln square is equal to Lm square plus Mn square, and this would be by Pythagoras theorem. So Lm is 8 square, Mn is 15 square. Okay, and in some cases the k method is used. So if you use the k method, then you put k over here as well, and this will give you ln square 64k square, and this will give you 225k square. Okay, so this will be ln square 225 plus 64 gives us 289k square. So square root of both on both sides will give you ln equal to 17k. Okay, that would be the answer. That means ln is equal to 17k or 17 centimeters we would get. Okay, now you can say equal to 17, ln equal to 17 centimeters. So the next part we find out about sine of n. And redraw the diagram on this page as well, so that we can follow it well. Okay, there you go. So the right angle was here. This is m, this is l, this is n. We've got this as 15 centimeters, we've got this as 17 centimeters, we've got this as 8 centimeters. So sine of n we are asked. That means this is the angle, and sine of any angle is opposite upon hypotenuse or perpendicular upon hypotenuse, as some may call it. So that is what lm upon ln. So ln will always remain the hypotenuse, because the hypotenuse is the side that is opposite to the right angle. Right angle does not move, will remain here. That means hypotenuse will always remain the same. So lm is what? Lm is 17, and ln, sorry, lm is here. Lm is 8 and ln is 17. So 8 upon 17 is the answer. You can, if you take the k method, it will cancel and you will get 8 upon 17 as the answer, which is sine n. Next we are asked for tan of L, which is opposite upon adjacent, or as some may call it, perpendicular upon the base. So tan of L. Now the angle is this one. So opposite will become mn, and the base or adjacent will become lm. So mn is 15, lm is 8. That is the answer for this one. Question 39 says, in the adjoining figure, the sides AB and AC of triangle ABC are produced to points P and Q respectively. If bisectors BO and CO of angle CBP, so this is a bisector of angle CBP, and CO is a bisector of BCQ, they meet at O. These bisectors meet at O. Then you are asked to prove angle BOC is half of combined x plus y. Okay, so we'll start with what we've been given. So what we can say is proof. So first thing we'll start with is this particular angle. Let's say this is this angle plus this angle plus this angle is 180 degrees, because this is a straight line. The straight angle is 180 degrees. So we can say that x plus angle CBO plus angle OBP equal to 180 degrees, and say angle on a straight line. We know angles on a straight line are supplementary. Okay, so we'll go through the figure once again. We said x angle CBO, x is here, angle CBO is here, and we said angle OBP is here. So this plus this plus this equal to 180 degrees, and we mark this as 1. Okay, similarly we can say y plus angle BCO plus angle OCQ equal to 180 degrees. Okay, angles on a straight line, once again the other side. Okay, and mark this as 2. Which one of y? Here. Then BCO. BCO is here, this angle. And lastly OCQ. OCQ. So this angle. So this angle plus this angle plus this angle, this full angle is 180 degrees. Just like how this full angle was 180 degrees, this is also 180 degrees. Okay. Now, we can say now angle CBO equal to angle OBP because OP bisects angle CBP. Mark this as 3. What am I saying? Angle CBO, angle CBO, this angle is equal to angle OBP, is equal to angle OBP. So this angle is equal to this angle because OB is the bisector of this full angle CBP. So this angle is equal to this angle. Okay. Also, you can say angle BCO is equal to angle OCQ. Why? Because OC bisects angle BCQ. Okay, mark this as 4. BCO. BCO is here and OCQ. OCQ is here. So this angle is equal to this angle because OC bisects this full angle BCQ. Okay, and we've got 3rd and 4th. Okay, now what we do is we'll say substitute 3 and 4 in 1 and 2. Okay, substitute 3 and 4 in 1 and 2. Where we'll substitute now? Here. So we CBO and OBP. Now what we'll substitute? We'll change this OBP to CBO. And here also we'll change this OCQ to BCO. See, if we write OBP as CBO and we can write OBP as CBO because we have said over here OBP is equal to CBO. If we change OBP to CBO, it will give us 2 CBO. Same way, OCQ we have already proved equal to BCO. So if we can change OCQ to BCO instead of this. So we'll get BCO plus BCO. That means 2 BCO. Okay. So we'll get X plus 2 CBO, Y plus 2 CBO. Okay. So that's what I'll write over here. X plus 2 times angle CBO equal to 180 degrees. Okay. And you can say Y plus 2 times angle BCO equal to 180 degrees. Okay. We can mark this as 5 and we can mark this as 6. Okay. Done. Next. Now we say adding 5 and 6. So when we add 5 and 6, we get X plus Y plus 2 times angle CBO plus 2 times angle BCO equal to 180 degrees plus 180 degrees. Okay. Now this can be further written as X plus Y plus 2 times, we'll take common, angle CBO plus angle BCO equal to 360 degrees. Okay. Now angle CBO and BCO, where it is? Angle CBO and angle BCO is here. So these two particular angles. Okay. So we have over here and we can write that as in this way. X plus Y plus 2 times. We can change this to write 180 degrees minus angle BOC equal to 360 degrees. How did I get from here to here? See, look at this particular triangle BOC. Okay. This angle plus this angle plus this angle is 180 degrees. Okay. That you would agree with me. Sum of all angles of a triangle. That is angle CBO plus angle BCO plus angle BOC equal to 180 degrees. Okay. So if I'll show it to you on a different page. Okay. And then I'll turn this page. Okay. show you. Okay, see, so that give you better explanation on that. So we have our triangle over here. So I'll just work it out at the side in a rough color. You don't really have to show that. Angle BCO plus angle CBO plus angle BOC equal to 180 degrees. So this is what you would agree as the sum of all angles of a triangle. BCO plus CBO plus BOC. This angle plus this angle plus this angle is 180 degrees. That's what I wrote. Now, I can also write the same thing. I can take this BOC on the other side and I'll get angle BCO plus angle CBO equal to 180 degrees minus angle BOC, right? So I kept BCO and CBO where it is, but angle BOC, I took it on the other side of the equal to sign. And when I take it on the other side of the equal to sign, the sign changes. So from plus, it will become minus. And we'll get 180 degrees minus BOC. What is 180 degrees minus BOC equal to? It is equal to angle BCO plus CBO. And that's exactly what I have mentioned over here. Angle CBO and BCO I've written equal to 180. Sorry, here. Angle CBO plus BCO I've written equal to 180 degrees minus BOC. Okay. So same thing. And the next step is what? Is I will open up this bracket and multiply 2 into 180 degrees and 2 into minus BOC. Okay. That is our next step. So we have to do that here. X plus Y will remain the same. Okay. Then this will become 2 times into 180. So that is 360 degrees minus 2 times into angle BOC equal to 360 degrees. Okay. You see, I just opened the bracket. 2 into 180 give me 360 and 2 into minus angle BOC gave minus 2 angle BOC. 360 and 360 will go away. So when you take on the other side, it become minus 360 degrees minus 360 degrees is 0. And we are left with angle X plus Y equal to minus. So minus 2 times angle BOC also I can take on the other side, it will turn positive like this. Okay, I just took this on this side and it turned positive. X plus Y equal to angle BOC. Okay, and I can write the same thing as angle BOC equal to half of angle X plus Y. Because if this is 2 times means 2 into angle BOC. If I bring that 2 on the left hand side, because it is multiplied, it will become division. So it will become half of this full thing, X plus Y. And this is what was asked. So this is how we prove it. Hence, proved. Okay. Question number 40. It says in the adjoining figure, angle X is equal to angle Y and AB is equal to AC. Prove that AE is equal to CD. Okay. So we begin first by writing what is given. AB is equal to the proof. AB is equal to CB. Okay. Which is given to us. Okay. It's given over here that AB is equal to CB. AB is equal to CD. Okay. So we can say therefore angle BCA is equal to angle BAC. Angles opposite to equal sides. See, we are given AB is equal to AC. So that means BAC, okay, BAC is equal to angle BCA, this full angle. We are in triangle. So you can say in triangle ABC, you can put over here. Okay, angle is so done, and we mark this as 1. Then we say in triangle EAC and triangle DCA. Which is the triangle? EAC and DCA. DCA. So this triangle and this particular triangle, you can say angle AEC is equal to angle CDA, and it is given to us. See, we are told angle X is equal to angle Y. So ADC and AEC are equal to each other. Okay, X is equal to, so this is X, ADC is this one. X is equal to Y. Okay, now we can say angle ECA is equal to angle DAC. ECA equal to angle DAC. This angle is equal to this angle. And how? We had shown, right? This full angle is equal to this angle in this full triangle. And that is why this angle also belongs part of this particular triangle. And also this angle belongs part to this particular triangle. So we can say from 1. And you can say AC is equal to CA, which is common side. And therefore we can say triangle EAC is congruent to triangle DCA by AAS congruency rule. And therefore we can say AE is equal to CD by CT, hence proved. This is how we solve. Okay. Once again, I'll go through this. See, we are given AB is equal to BC. So because these two sides are equal to each other and they form part of this big triangle ABC, we can say this full angle is equal to this full angle. But this full angle is also part of these small triangles over here, which we need to prove as congruent to each other. So if we get this angle is equal to this angle, we have shown is equal to each other. And we are told that this angle is equal to this angle. And these two angles also are part of these two triangles. And this side is common to both these triangles. So because of angle and side, we can say that these two triangles are congruent to each other. And once we prove that these two triangles are congruent to each other, we can say that their corresponding sides, which is AE and CD, are also equal to each other. Okay, so that's how we prove this question number 40. And we come to the last question of section C, which is question number 41. Question number 41 says, in the figure given below, AD and BE are the medians of triangle ABC, full thing, and DF is parallel to BE. We have to show CF is 1/4 of AC. CF is 1/4 of AC. What we are given is that AD is a median. Okay, that means BD is equal to DC, and BE is also a median. So that means AE is equal to EC. And we are told BE is parallel to DF. Okay, B is parallel to DF. Okay, so if this is a median, that means this is a midpoint, right? This is also midpoint and this is also midpoint. So when there are midpoints coming, and there are also parallel lines coming, that means we need to use midpoint theorem over here. Let's see how we can utilize midpoint theorem over here and use maybe midpoint theorem or converse of it. Let's have a look. Okay, first thing, start by saying that AD, okay, is median of triangle ABC, which is given to us. Okay, so we say AD is median of triangle ABC. We can say therefore D is midpoint of BC. So I've just stated the obvious, D is midpoint of BC. And I mark this as 1. Also you can say BE is midpoint of AC. Okay, sorry, not midpoint, BE we are given as median. Okay, B is median of AC. So that means we can say therefore that E is midpoint of AC, and we mark this as 2. So we say E is midpoint of AC. Okay. Now we are also told that DF is parallel to BE, which is given to us. We mark this as 3. Then we say in triangle CEB, okay, which is a triangle CEB. So we have CEV. So this particular triangle, this full triangle, okay, this triangle, okay, we can say from 1 and 3, 1 and 3 is 1 and 3 by converse of midpoint theorem. By converse of midpoint theorem, we can say that F is midpoint of side CE, and mark this as 4. Okay. Now in this particular triangle CEB, okay, we are saying that from 1 and 3, 1 is D is midpoint. So D is midpoint. Okay. So in CEB, they say D is midpoint. And we are also utilizing the fact that DF is parallel to BE. Okay. And then that case, F becomes the midpoint. So converse of midpoint theorem is what? It tells us that if we have got one side, if we've given a midpoint of one side of the triangle, and we are told that the line from that midpoint is joining another point on the other side of the triangle, and that line is parallel to the third side of the triangle, then that point becomes the midpoint of that second side of the triangle. And that is what we have told. F is the midpoint of CE. In other words, if D is the midpoint of this side and a line from D to F is parallel to the third side of the triangle, which is B, then F should be the midpoint. That is what we have done over here. And we mark this as 4. You can say now AC is equal to AE plus EC. What is AC? AC is this. And we are told AC is nothing but AE plus EC, full thing. Okay. Now, AC equal to, we can say EC plus EC. Okay. Why? AE and EC it was, right? But E we know is a midpoint. So we can write AE is equal to EC. So we can write EC, AE is same as EC. So we can write AE as EC and EC plus EC it will become. Can say from 2. 2 was what? E is the midpoint of AC, which means AC becomes equal to, AE becomes equal to EC. And now we have got AC equal to 2 times EC. Okay. Now, EC we can write as EF plus FC or CF, whatever. Okay. EC we can write EF plus FC. Here. EF plus FC. EC we can write as EF plus FC. No. We can further write this as AC equal to 2 times into now EF. Now we have said F is the midpoint, right? Of F is the midpoint of EC. So that means, see, we have mentioned it over here. F is the midpoint of CE or EC. Okay. So that means EF is equal to FC. And so we can write this as 2 times FC. This will become AC is equal to 2 into 2, 4 FC. Okay. When you take 4 on the other side, it will become half. So that means, therefore, you can say CF is equal to 1/4 of AC. And that's what we were asked to prove. Hence proved, you can say. Done. Coming to section D, says 4 marks, 2 questions are there. Question number 42. Factorize the polynomial a cube plus 13a square plus 32a plus 20. Okay, so I'll just write it down first. That is a cube plus 13a square plus 32a plus 20. So we need to remove, we need to write down all the possible factors of 20 and just try to find out which factor, which of them will be a factor of this particular polynomial. I'll show you how. So we say let p of a, because the polynomial is in a, p of a equal to a cube plus 13a square plus 32a plus 20. All possible factors of this 20 will have to of p of a. So basically we just look for factors of 20. So 20, 20, and if you factorize 2 10s are 20, 2 5s are 10, 2 5 ones are 5, so it's 2 2 5, so 2 4 5, all of these will become factors. So just 2 and 5 you can say. 2 we can write r plus and minus 5. You just write plus 5 minus 5 plus 2 minus 2 plus 1 and minus 1. Okay, these are all the possible factors. Now if you look at this, these are all positives, so we rule out all the positives because they will all not give us. P of a should become equal to 0 whenever if we submit one of these. If it is a factor and if we substitute in place of a, it should give us p of a equal to 0. That will not happen with positives, so it will only happen with negative ones because they all are positive. So I'll start with a equal to minus 1. So say when a equal to minus 1, say p of minus 1 equal to, substituting in place of this, so a instead of a cube we put minus 1 whole cube. So instead of, because we have taken a equal to minus 1, so wherever there is a we put minus 1 plus 13 into minus 1 whole cube, do not forget the powers, plus 32 into minus 1 plus 20. This gives us minus 1 whole cube is minus 1. Minus 1 whole cube does not mean minus 1 into 3, okay? It just means minus 1 into minus 1 into minus 1. 3 times minus 1 is repeated. Plus minus 1 whole square is positive 1. Positive 1 into 13 is positive 13. Minus 1 into 32 is minus 32 plus 20. Okay. So minus 1 plus 13 gives us positive 12. Positive 12 minus 32 will give us minus 20. Minus 20 plus 20 gives us 0. So p of minus 1 equal to 0. That tells you therefore a plus 1 is a factor of p of a. For those of you are wondering how I got a plus 1, see, a minus 1, if we bring minus 1 on this side, it will become a plus 1 equal to 0. That is your g of x actually. Okay. So a plus 1 is a factor of minus 1, or you can just say minus 1 is a factor of p of a. None. Proceed further. So now we proceed to the division part. Okay. So we say a plus 1 divided by the polynomial that is given to us, which is a cube plus 13a square plus 32a plus 20. Here we have a cube, here we have a, okay. So we need a cube over here, and since there is a difference of power over here of 2, so we put a square over here. A into a square gives us a cube. The positive sign which is over here comes around over here also, same thing. Plus 1 into a square will give us plus a square. We change the sign throughout. Sorry, this became too long. Cancel. 13a square minus a square gives us positive 12a square. Plus, bring this down, 32a. Now there's a square over here, which means, and there is positive sign. So with positive sign here, we need a into a gives us a square, and there's the coefficient of a square is 12. So we'll need a 12 over here. to get 12 over here. A into 12a gives us 12a square. 1 into 12a will give us positive 12a. Change the sign throughout here. And this will cancel. 32 minus 12 will give us positive 20a. Bring that positive 20 down. Okay. Now, the powers are the same, just the there's an extra coefficient. The coefficient of a over here is 1. The coefficient of a over here is 20. So we need plus 20. To get 20a, 1 into 20 gives us positive 20. Change the sign throughout. This will cancel. This will cancel. And we get our divisor over here. Okay. So we can write P of A equal to, so we actually write P of A, the remainder theorem. So P of A division algorithm. So P of A is equal to your Q of X into G of X plus R of X. Okay, so P of A is your A cube plus 13A square plus 32A plus 20. Okay, your quotient is this Q of X is square plus 12A plus 20. G of X is A plus 1 and R of X is 0. Okay, this we can factorize further. A square plus 12A plus 20. So this will become A square plus 10A plus 2A plus 20 into A plus 1. So we take common A out of here. So we will get A into A plus 10. And here we'll take 2 common. So we'll get A plus 10 over here. Close the bracket into A plus 1. So here we'll get A plus 10 common on factors and A plus 2 and A plus 1. So these are the factors of the given polynomial. This is how you find out. This is for 4 marks. The last question of this paper says, given in the adjoining figure in triangle ABC, B is a point on side AC such that DE is equal to DF, AD is equal to CD, DE is perpendicular to AB at E, and DF is perpendicular to CB at F. Prove that AB is equal to BC. AB is equal to BC. That is what we need to prove. Okay. We begin with what we have been given here. We say in triangle DFC and triangle DEA. Okay. DF is equal to DE given. DC is equal to DA given. And angle DFC equal to angle DEA equal to 90 degrees, and that is also given. And therefore we can say triangle DFC is congruent to triangle DEA, and this would be by RHS congruency rule. We'll just quickly have a look. See, we have been given DF is equal to D. We are taking which triangles? DFC, this triangle, and we are taking this triangle. So we are trying to prove these two triangles are congruent to each other. Now this is 90 degrees, this is 90 degrees, which we have said over here. Okay. We are also given that DF is equal to DE. We are also given that DC is equal to D. So we have got a right angle over here, and the side opposite to the right angle becomes the hypotenuse. That is also given to us as equal. Corresponding ones are equal, and another side is given equal. So by RHS congruence rule, we can say that these two triangles are congruent to each other. So we can say that FC is equal to EA CP CT, and we mark this as 1. So we can say which one? FC, this part is equal to EA as CPCT. Now, next, in triangle PFD and triangle BED, we can say that FD is equal to ED, which is given to us. We can also say that BD is equal to BD, which is the common side. And we can say that angle BFD is equal to angle BED equal to 90 degrees, which is given to us. And therefore, we can say triangle BFD is congruent to triangle BED by RHS congruence rule. Okay, let's have a look. Triangle BFD, this triangle now, and triangle BED, this triangle. We're trying to prove now these two triangles are congruent to each other. We know this is 90 degrees here and this is also 90 degrees. So these two angles. Then they are hypotenuse. Both they are hypotenuse as the same BD. So this is a common side. And there is another side that is given to us as equal to each other. That is FD is equal to ED. So by RHS congruence, we can say that the two triangles are congruent to each other. Okay. And now we can say that therefore BF is equal to BE by CPCT, and we mark this as 2. BF, where is BF? BF is here. So we have got this equal to this. Now BF we are saying equal to is BE, this. Okay. Now we got 1 and 2, and now we say adding 1 and 2 we get, okay, so 1 is this FC plus BF. So left hand side I've added together, and now I'm going to write the right hand side EA plus BE. So I would added that. Now FC plus BF. FC plus BF is nothing but BC. Okay, so this is BC, and then we have EA plus EB or BE. This full thing is AB. So we can say this is equal to AB. And we can say hence proved. This is what we were asked to prove. So with this, we complete this model paper. Okay. And I hope you found this paper solving very useful in your preparation for the exam. If you like watching this video, do please hit the like button, share these videos with your classmates and your friends. Do not forget to subscribe and ask your friends also to subscribe to this channel. More videos will be coming up, okay, now and in the future. And please do join the membership by hitting the join button near the subscribe button. Because if you want any particular videos to be done, I will do it exclusively for you. It's for a small minimum fee of 59 per month. You can always withdraw from that anytime. So these videos will be only in the membership area and will not be available to others. Okay, whatever you request. Also, the other thing is, if you want, you can follow our WhatsApp channel also. The link for that is in the description box below. Any new updates you will get over there. New videos that come up will get posted over there. So that's another way you will get notified. If there is a new circular come, it will be put up over there. Any such information. If let me know how you find this video in the by commenting in the comment section. Okay, and if you want any particular video to be done, please let me know. Any other suggestions are welcome. So thank you very much for watching this video. I request you to keep watching more such videos. Thank you and all the best for your examination.